States, 150 microservices, all written in Go. And how do you go put in a new feature or a bug fix when you have 150 services and your service is like number 12 in the service call graph, right? That's really hard. Some people don't feel like they don't need inner loop solutions, and typically when you look at their environment, so I'm doing microservices. You look closer, you're like, wait, that's 2 websites. That's not microservices, right? Very common, right? But when you're doing real microservices, the inner loop starts to become important. And so I have a philosophy on the inner loop, mainly around testing the inner loop, which I think is the hardest part about this. Obviously, we know how to sit down and write code. The testing is where this gets challenging. So the philosophy I like to apply to this is unit test locally, right? Unit tests are great. Write them, lots of them. You want to have good code coverage on unit tests, but you also want to recognize that unit tests should be in-memory tests. They should run fast, they should finish fast, and they're only going to provide so much guarantee by design on the software quality, right? Especially in the context of a big distributed system. So how do you test the big distributed system? You do that integration testing remotely. Remotely as in the context of a Kubernetes or large runtime environment. And this is important because, first of all, if you look at practices in the industry, Twitter, Uber being 2 good examples, they don't ask developers to test code on their laptop. Why? Because you can't model Twitter on your laptop. There's not enough memory. Even if you could put enough memory, you still couldn't model the data dependencies and the service, all the complex service dependencies. So I think as an industry, we need to stop telling people that you can use Docker Compose on your laptop for anything more than just sort of rough cut at implementation. Maybe your Ruby on Rails app, you can make work in integration tests with Docker Compose. If you're building a big distributed system, you got to do it remotely. So that brings us to our next point, continuous integration. What have I learned about this? Well, one important pattern is that you want to make sure that your CI configuration lives inside your source repo. All too many companies that I come across are running Jenkins, let's say, and the Jenkins configuration is set up and maintained by a Jenkins administrator. But if that Jenkins administrator gets hit by a bus or quits or the Jenkins server tips over, no one knows how to recreate the build environment and the build file. But if instead your config for those repos lives inside, or your config for CI lives in the repo, you just go back to your CI server, add repo, add repo, add repo, add repo, done, right? And this is very, very important, and not enough people are actually doing this today. But every major CI system supports this. Jenkins supports this. Azure Pipeline supports this. Definitely use this practice. It will save you. The next thing I want to talk about is a focus on artifacts. Back when I was first doing CI system rollouts, a lot of my work was on building Debian packages. This is back in 2006, 2007. And so I would go in and help companies package up software, build Debian packages, publish them. And the CI systems, this was like early cruise control and systems like that, the CI infrastructure was all focused on building, testing, and creating artifacts. And that was it. Done. There was no concept of deployments. That was a separate system. And it actually worked really well, having deployments as a separate system. We would do parallel SSH to apt-get update and apt-get upgrade, all of our boxes, right? And that was how we did deploys. And we had a lot of hygiene, and we could sort of control how deployments happen, separate from how the software delivery happened. But there was also this thing that happened where someone cleverly said, oh wait, if I add a deploy at the end of my CI script, then my green build now is a green deploy. And I don't need to build a separate system for managing my deployments. Isn't that nice? It is, but it's actually a bad practice because it turns out that over time, you're going to lose a handle on the artifacts that you're delivering. It's going to make it harder to do rollbacks. You're not going to be able to distribute your software to another environment if you need to, because you've coupled the environment to your delivery pipeline. So it works for some people, and I would be lying if I said we don't do this in Azure. We do this in Azure. So, but it is better hygiene to have your CI strictly focus on artifacts. But again, see if you can do that decoupling of CI/CD. One of the examples I like to point to is IoT, right? In IoT, you can't model your deployment topology in a CI pipeline, right? Because you have thousands of devices constantly entering and leaving the picture. So if you're not doing artifact delivery and then having a subscribe model for your software consumers, you're unable to deploy, right? In other words, if you couple your CI and CD, you can't build IoT systems, period, right? And so, anyway, something to think about as you're working on this. Now, on continuous deployment, continuous delivery, a couple things I've learned, and really goals, I would say, for me. One is I want to really make it safe to deploy. There's a thread going around on Twitter that was talking about how being afraid of doing deployments is a really good sign of technical debt. And it's true. If you can't do deployments because you're afraid that it's going to break your whole system, I feel bad for you, and I hope we can make it better. But this is something that we need to, as an industry, work towards. And this is, honestly, one of the things that we at Azure are doing a lot of work. I can share a little bit more detail on that. Smoke testing becomes very important to making it safe to deploy. Smoke testing is the concept that you blow smoke at your application as part of your testing process and see how it stands up, right? So it's not a very deep test, but it's a very good early warning system that something is broken. Now, I like to apply smoke testing at every layer. So I like to apply smoke testing in CI. So, after I build and unit test an artifact, Manuel probably remembers this in days, we had functional tests that would make sure that the container that we just built would start and listen on a port that we expected it to be listening on, and could even do a little bit of protocol, exchange with that port. Very good smoke test. But even better is to do that smoke test in prod, right? So when before the container comes up, and this is what Kubernetes health checks actually do for you, is they will allow you to smoke test the container before it will actually run. And so as long as your end-to-end test includes something that has a Kubernetes health check in it, you're getting some degree of smoke testing of your app. So making this easier is something we need to do for developers. Another big one is feature flags.
Can you apply the same when you turn off Kubernetes?
Sorry?
Can you apply the same when you turn off, when you shut down Kubernetes? I mean, if you grow.
Can you apply, when you shut down Kubernetes, can you have,
operation? I understood that you apply smoking tests even in production.
Yes.
Yeah, so it's a problem if you don't shut down correctly the Kubernetes, and you will get a big bill at the end of the month. So making sure that you're shutting down all the Kubernetes after you leave it. Is it possible to apply the same concept?
You know what? I'm going to show you a demo later on about my thoughts on cost controls for Kubernetes, and so you can get a sense of that. But one thing I will mention is when you shut down a VM in Kubernetes, and say you want to scale your cluster down to 0, Kubernetes has a whole bunch of logic built into it that will gracefully terminate workloads. And it will, there's even things called pod disruption budget that will make sure that you're not disrupting a lot of your active containers in production as you do things like rollout and upgrade. It will slow down basically the change, infrastructural change of the system. So lots of different things akin to smoke testing that you can do with Kubernetes. But I'll touch on the cost control in a minute because I want to show a pretty cool demo on that. For feature flags, this is something that we do in Azure very heavily, and this is something that at scale, a lot of mature organizations do. And what this is around is decoupling the act of building and shipping software features with turning those features on, right? What you want to do is you want to be able to put in code paths for a feature, roll that out, and then once it's out in production, slowly start experimenting with turning the feature on for a subset of traffic, right? There's lots of frameworks out there that can help with this. It's actually not that hard to write your own. The key to it is you want it to be dynamic. You want to be able to say, all right, let me quickly turn it on, watch a little bit of traffic, and turn it back off, and then decide whether you want to actually leave it on or whether you want to turn it off. This greatly, because you can do that sort of dynamic on off much, much faster than you can roll out of deployments to potentially global infrastructure with lots of different dependencies. Also, you can manage your data dependencies much better in this environment. It ends up being a good model. Ultimately, at the end of the day, the thing that we want to do the most, the thing I want to do the most, is make it safe and easy and automatic to do canary deployments. Anyone familiar with the concept of a canary deployment? No? Okay. Canary deployment, the name comes from a canary in the coal mine. Anyone know what a canary in the coal mine is? So they used to bring canaries down into mines, literally, bring a bird into the mine. And if the gases in the mine were getting bad, the canary would drop dead. And then everyone would go, uh-oh, we gotta get out. And they would run out of mine. And so in software deployments, we have a similar concept, which is we do a deployment and we see how it goes. Does the canary drop dead or does it stay alive, right? And if the canary stays alive, then you proceed with the deployment, right? And you, so typically the way this will work is you'll deploy out to 5% of your traffic with your canary. And if your error signals look good and your monitoring looks good, then you will promote the canary, maybe slowly, maybe you promote 10%, then you promote to 50%, then you promote to 100%. And today, any big major site that you visit on the internet, any of the big ones, most of them are doing this already. Because honestly, you learn that you have to do this. There is no other choice, right? What I want to do though, is I want to make this easy. I want to make it so that people who are writing software for Kubernetes get it for free. And there's a lot of work that we're doing in that area. Most of it comes down to the concept of observability. Because ultimately, canary deployments need to be driven off of telemetry and monitoring that's coming off of the application workload. So the biggest principle for me is I want this instrumentation for free. And one of the ways that we're starting to see this come in the industry is through the concept of a service mesh. Who here is familiar with service mesh? Who here is not familiar with service mesh? Who here knows why service meshes got created? Let me explain this. So this is actually kind of fascinating because in the industry, we've gone the last 30 or so years of having a principle in networking called smart endpoints and dumb pipes. What that means is that you encode the logic for the network in the endpoints. And the pipes are just dumb. They just forward packets, right? And the whole internet is built on this concept. All of modern networking is built on this concept. And what a service mesh is doing is it's actually changing that paradigm and it's saying what we actually need, we don't want smart, we want, dumber endpoints and smarter pipes is really what service mesh is. And if you think about why that is, why did that change? Well, we had an explosion in the number of endpoints. And so when you explode the number of endpoints, now things like compression and encryption and identity and release management and distributed tracing and all of these problems, if you want to solve a change or if you want to make a change to compression, how you do compression, and you have 150 microservices, you have to coordinate a rollout across 150 microservices and have branching logic says if compression algorithm is this version, do this, and otherwise it's this, and all brittle logic. And by the way, you're not going to change that compression once, you're probably going to change it 4 times until you get it right. So now you forever in your code have 4 branches for the different compression logic. That sucks, right? So instead, what you do is you move different parts of the logic to the pipes. You move compression into the pipes. And now the pipes are adding all of this functionality. And one of the interesting things is this technology is how we get service-to-service telemetry, because what ends up happening is you deploy something like an Envoy proxy sitting next to your workload, and then every time your workload makes a call to another service, it will go through the proxy, and that proxy is collecting data on traffic flows, how many errors there are, what the latency is for every single request you make, either in or out. And you can then aggregate all of that telemetry, and you can start to build a system where you can automate things like canary deployments. But I mentioned some of the metrics that are important. Request throughput. You want to know, how much traffic is getting sent through all of your service-to-service requests. You want to know how slow your requests are. Because if one release of your application